Thank you, Dennis. Appreciate that. I'm very grateful to Dr. Hanasak. He was actually on the hiring committee that hired me here 15 years ago. And so he's always been one of my favorite guys since I can thank him for my job. So what I want to talk about today is some of the work that we've been doing in my lab over the past 9 years, looking at this annual migration of these black-tip sharks. Have you seen this sort of stuff before with these large numbers of sharks close to the beach? Well, this project actually stemmed from some inquiries I would be getting. Every winter, I would get calls from local media stations, local television stations, who'd say, hey, there's a whole bunch of sharks on the beach. Should we be concerned about this? What's happening? And their news helicopters would get pictures like this with sharks all over the beach. There's people on the beach over here deciding, should I go in or not? But given the large number of sharks, they typically don't, which is wise. And you could have people like literally walking along the beach, like this guy walking along, and there's like sharks. There's like a dozen sharks in the water right here, showing how close they are to the beach where the people are. And sometimes, if you're particularly fortunate and have one of the nice houses along the beach, you could have sharks right in your backyard, which I think would be great, but the owners might not. And so what the motivation was for this was answering the questions from the local television stations. And they would say, why are there so many sharks here? What's going on? Should we be concerned? And I, as a good scientist, went to the literature to say, what do we know about this shark migration? Now, locals down here in South Florida, they're familiar with this. I mean, if you've been living here in Florida, you know that every winter the blacktips come down. But a lot of people who are snowbirds coming down here in the winter don't know that. And they see this and they panic. And so I dug through the literature to see what I could find about this annual migration of sharks. And I found that there was hardly anything. I was surprised at how little we knew. And so I determined that the best way to study this is to go into the sky. Study the sharks from the sky, because that's what the news helicopters are basically doing. And so if I get that top-down perspective, I can see what's going on. And that was the motivation for starting this as an aerial survey. And so I started an aerial survey back in 2011. And what I did was take a Cessna 172, a little fixed-wing airplane, and I would mount a high-definition video camera out the open window of the pilot side here and a digital still camera behind it. And we'd fly along the beach. We'd fly initially just along Palm Beach County, so just covering Boca Raton up to Jupiter. And then subsequently, a few years later, as we continued to do this, I expanded the range and went all the way from Miami up to Jupiter. It's covering the whole Tri-County area, Miami-Dade, Broward, and Palm Beach counties. And we'd fly 500 foot, which is one of the preferred transit through Fort Lauderdale airspace and Palm Beach airspace. And we would capture video along this whole length and then go back, and my student Sherry here would go back and analyze the video to count the numbers of sharks. And so just to give you an idea what this looks like, this is sort of the cartoon view of the scenario. You have the airplane up here. It's flying out of the screen toward you. Right, here's the beach over here with the little beach umbrella. And then the sharks in the water. And what the cameras are seeing is a field of view that extends from the plane down and about 200 meters across. So it's about 1 football field, 2 football fields length, right? 100-yard football fields, all right? 2 football field lengths from shore. And we would count the numbers of sharks that we saw adjacent to the beach. Now, we know that there's others out here, but, I mean, you can only do so much. It's an ocean. You know, you have to cut it off somewhere. So we would just count the sharks adjacent to the beach. And the nice thing about where we are down in South Florida is it's pretty shallow at 200 meters off. And you can see all the way to the bottom. It's only about 4 meters deep. So you can see from the surface down to the bottom, we have a light sandy seafloor and clear water and dark sharks. And it enabled us to see the sharks from these aerial surveys. And this is what the camera would see. So this is a single clip, a single frame from the video. And you can see the beach along the left-hand side of the screen here. You see the strut on the plane and the wheel, and every one of those little dots is a shark in that frame. All right. So if you were to guess, how many sharks are there? Go. You've got 2 seconds. We're flying at 70 knots. Go, go, go. 700, 2,000, 3,000, 1,500. You got it. There's 1,678 sharks in that frame. 1,500 is the winner here. And so I'm just going to show you what that video looks like, to show you just a 30-second clip, so you have an idea what we're looking at here. And this was from when we first started, our very first season, in fact. And this is as we're flying along. The camera is recording, and you can see all the sharks popping up along the beach here. All right, and it's an airplane. I can't go any slower. This is pretty slow. But you can see the sharks just continue. There's the shore here. And again, it's about 1 football field to 2 football field lengths. But look at all these sharks. And there's no way you can count that in real time. You can't count that as you're flying. You have to record this and go back and analyze it after the fact. And that was my student's job. I'm not going to do it. I'm going to get a student to do it. Go back and count the sharks. But just as a reminder, there's the road. You can see A1A, right, on the left-hand side of the screen here. And you can literally be driving your car and toss a rock and hit a shark. They're that close to the beach here. And so when we would take this video footage back from each flight, we do flights about every couple of weeks. We'd take the video back to the lab, and Sherry would sit there for the next 2 weeks counting little dots on the screen. But she got such beautiful data. What I want to show is just this first clip showing the years that we've been doing this study and the number of sharks, okay? Just focus on the first couple of years here. You would have huge numbers of sharks, 12,000 sharks or more, and then it would drop off precipitously to hardly anything throughout the rest of the year. Then a few months in the wintertime, January, February, March, lots of sharks and drop off again. Now, 2013 was a little unusual, and what happened in 2013 was you had a lot of these beach renourishment events. You know this, where they take the sand from offshore and they pump it onto the beach to make the beach bigger. But in the meantime, it sets up this enormous silt cloud, and you can't see anything. And so our numbers were really low that year, and it might have been because we couldn't see anything, or the sharks might have been out in, away from the silt. We don't know, but that's why the numbers were so low that year. They bumped up again in 2014, right here, back to basically where they were before. We're going to come back to this decline in just a second. But I do want to show you how we came up with these numbers and what they mean as we're going along the whole coast here from Miami up to Jupiter. Now, we know that along the coast, it's sort of divided into these nice little inlets. Jupiter Inlet, Palm Beach Inlet, Boynton, Boca, right? And these are nice because you can see these from the plane. They're giant inlets. You can tell as you're flying along where you are. And we know the distance between them. We know that between Palm Beach Inlet and Jupiter Inlet is 19.3 kilometers, right? Same thing, Boynton to Palm Beach, 25.2 kilometers, all right? So we know the distance between them. We know also the transect is about 200 meters wide, remember? 200 meters from the beach out. And so we know the width of the transect, and we know the length. And so from that, you can calculate what the area is in each little segment here. And from those areas, we can sort of use that to calibrate for some inlets that are much farther apart versus some inlets that are much closer. They have different sampling areas, and we count the numbers of sharks in each segment, and we're able to get the density. How many sharks per square kilometer as you're going along here, okay? And if you look at the shark density over time, this is just baseline data in December, before the sharks get here, right? This is, you remember those low periods where there's hardly any sharks? And if you look, we're averaging maybe 0 sharks per square kilometer, 1 shark per square kilometer. Boca had up to 6 sharks per square kilometer. That's the sort of numbers that we're looking at in off-season before the sharks get here. But then, just literally 2 months later, if you look at February, in peak season, you see the densities, the packing density of sharks changes dramatically. And you're not talking about 0 or 1 shark per square kilometer. Now you're talking lots, hundreds, or literally thousands of sharks per square kilometer. In fact, we have numbers off between Palm Beach and Jupiter. It goes off the screen. It's over here somewhere. It's 1,231. That wasn't even the biggest number. We've had densities that are in excess of 2,500 sharks per square kilometer. That's a lot of sharks packed into a small area. And it's an average, but it gives you an idea. And when I say something like that, it's hard to get a grasp. 1,231 sharks per square kilometer. What does that mean? How do I wrap my head around that? So think of it this way. If you were out there snorkeling on the beach or off your boat somewhere, right? On average, you would have a shark no more than 16 meters away from you. All right, and that's about right. All these people snorkeling off their boat, not realizing there are literally 200 plus sharks right here, right beside them, without even knowing it. And so that's what we're talking about. Next time you're at the beach in the wintertime, take a circle, 16-meter circle around yourself, and somewhere in that circle, there's probably a shark on average. All right. That's what I mean. That gives you an idea of what we mean by this sort of density. So let's go back to that figure I just showed you a second ago, the numbers of sharks over time. And you'll notice a couple of things here. The seasonality is very distinct. Huge numbers of sharks, then pretty much nothing. Huge numbers of sharks, pretty much nothing. We stopped flying in the summertime because there were no sharks, and we started increasing the number of flights in the wintertime to capture more data. Right? So more flights during peak season, and what we found was that there's this strong correlation between shark abundance and water temperature. And so when you have lots of sharks, it's when your temperature is really low. When the temperature is high, there's very few sharks. So it's this inverse correlation. When one is up, the other's down. Lots of sharks, low temperature, high temperature, few sharks, right? And this sort of temperature trend continues over time like this. But what you can look at is the number of sharks that you get with temperature, and you see that you only get the big numbers of sharks when the temperature is less than around 25 C. Right? And so you're only getting large numbers at lower temperatures. High temperatures, you get very few little sharks down here. Because the numbers of sharks are correlated with temperature, I want to show you another figure that we found interesting. We looked at temperature over the years that we've been doing this study. And this is the average daily water temperature between January through April, when the sharks are here. And from the time we started in 2011 to 2018, temperature has been slowly increasing all those years. And what do we see with the sharks? What do you think is going to happen with the shark abundance? Shark abundance is going down at the same time. It was not unusual for us to get 12,000 sharks on a flight when we started. Last year, we barely broke 3,000. It's dropped dramatically in just a few years. And it's correlated largely to this change in water temperature. Now, I don't have the data from this year yet because I literally flew a survey flight this morning on the way up here. So we're still in the process of collecting the data. But I'm curious to see what happens with water temperature in 2019 and numbers. I can tell you anecdotally, the numbers this year are better. They're around 5,500 at peak, which is still half of what we would typically get with when we started. But we'll see how the data pan out. So we've got this strong correlation with temperature. We know what's happening when they're down here for a few months in the wintertime. But we don't know what's happening after they leave. We can study them when they're here, but they're only here for a few months. And so that led to the next step. That led to looking at the movements of these sharks, their migration along the coast as they're leaving South Florida. And so to do that, what we were doing was instrumenting the sharks with acoustic transmitters. We'd go out fishing, we'd catch a shark, bring it up beside the boat, and we make a little incision in the belly, stick a transmitter inside it, and then suture them back up again and let them go. And once you've stuck the little transmitter inside them and let them go on their merry way, off they go swimming along, but now they're pinging. Now they've got this little transmitter that's going ping, ping, ping. Every 2 seconds it's going ping. And it's sending out a unique ID code. Well, pinging is only good if someone's listening, right? It doesn't do any good if no one's listening. And there is an array of these listening stations all along the coast. It goes from the Bahamas all the way up to Canada, and there are literally hundreds of them. These dots do not represent every one, they represent several. And so there are lots of these receivers all along the coast here, and they are anchored to the seafloor, and they sit there listening for any of these transmitters that go by. And so what happens is, this is another cartoon illustration, the receiver is anchored to a float on the seafloor, and the float keeps it upright in the water like that. And it's listening. So anytime a shark with a transmitter swims by and goes ping, 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 that receiver detects that information. It knows the unique ID code for that shark. It logs the date and the time that individual was there. And it sticks all that into memory. And then what we do is every now and again, we go off on our little boat, go scuba diving down, pick up the receiver, bring it up to the boat, download all the data onto the laptop. Then we go diving down again, take the receiver, anchor it back up again, go back in the boat, and then we go home and we look at our data. And we share the data with everyone. So we have our receivers here, other researchers have their receivers up the coast, and we're all part of this Atlantic coast network. And so we're able to share information back and forth. If we detect one of their snook, we let them know. If they detect one of our sharks up north, they let us know. And we're able to leverage this array of receivers to get movement data along the whole eastern seaboard. So what we've done so far is we've instrumented 52 sharks with these acoustic transmitters now, okay, all off Palm Beach, Florida, where we operate. And we've heard back from about 80% of them, which is actually pretty remarkable, considering you're taking this little thing and you're literally throwing it in the ocean and saying, I hope I hear from you again. And we heard back from 80% of them, which I'm really happy with. Now, what's interesting is if you look at the literature, it states that these blacktip sharks, they rarely go north of Hatteras. All right? They're basically southeastern, have a southeastern distribution. And Bigelow and Schroeder wrote, blacktips occur north of Cape Hatteras, North Carolina, only as a rare stray. All right? And so they're basically saying they go from the Carolinas down to Florida and then back again. You know, summer's up here, winter's down here. What we found was that 24 sharks, 60% of them were detected north of Hatteras. That's not a trivial number. That's not the occasional rare stray. That's the majority of sharks are going well north of what the established northern limit was for this species. And in fact, if you look at the northern most detections for the sharks that we've heard from again, some of them we never, we heard from them on our receivers here in South Florida, but some of them, the majority of them were actually heard at much higher latitudes, as far as Long Island, New York, in fact. So these sharks are going way up there, much farther than anyone had suspected, much farther than Cape Hatteras. And in fact, the majority of them are up in Delaware and up to Long Island. And so the historic range for these animals has always been something like the Carolinas down to South Florida. But what we're seeing now, that historic range established 70 years ago, is actually shifting. These animals are going much farther than they were just a few decades ago. And interestingly, in that same time period, sea surface temperatures have increased by 0.85 degrees. And so the water temperature is rising. You're getting warmer water at higher latitudes now. And it's probably one of the driving factors, since these sharks have this very nice preferred temperature band. They're finding that temperature at higher and higher latitudes now than they ever did before. And it's resulting in this shift in their distribution to higher latitudes. We see this not only from the acoustic data that I showed you with all the hits on those different receivers. You can look at satellite transmitter data. We've instrumented sharks with these little satellite transmitters. So you bring the shark up beside the boat, and there's my student Beth affixing a transmitter to the dorsal fin here. And that has an antenna, and anytime that shark's fin breaks the surface of the water, that antenna will talk to an Argos satellite orbiting overhead. in order to give it the latitude and longitude and the water temperature, and it says, I'm here, I'm here, I'm here, and the temperature is XXX. And so we can look at these sorts of tracks, and you can see the shark instrumented, in this case, in March of 2017, and we got hits all the way up the coast, up to, in this case, it stopped transmitting in a few months later in June, but it was off Hatteras there, all right? This indicates a couple of things. Number one, it's good corroboration for the acoustic data that these sharks are making this trip up here. Number two, it shows that they are hugging the coastline. One of the ideas that had been put forward in the literature before was that these sharks were hitching a ride on the Gulf Stream. They were, going offshore here and riding the Gulf Stream up to higher latitudes and then jumping off where they needed to. We found that that's actually not the case. They're swimming it the whole way. They're not getting a free ride. They are swimming right along the coast all the way up there. And so we have this, two lines of evidence pointing to how these sharks are migrating along the coast and then coming back. We get them back here again the next year. They're picked up on our receivers the following year. So they're tagged here. They go up north. They're detected up there. And then they're detected back here again next year. These transmitters last for at least 6 years, and so we're able to get multiple migratory excursions back and forth. Well, this gives you good data on long-distance movements, but we're also interested in seeing what the sharks are doing when they're down here. Remember, they're spending a few months here every winter, right? They're snowbirds. They come down, spend the winter down here in Florida, then they go back up north again. And so what are they doing when they're down here? The other snowbirds, play golf or whatever. But what are the sharks doing? So we wanted to get a good idea of what the behavior of the sharks was when they were down here in South Florida. And so to do that, we've been using these new data logger tags, which are basically a little daily diary. It tells you what the shark is, where it's going, how deep it is, what the water temperature is, what the light level is, how fast it's swimming. It's like it gives you 3-axis acceleration, magnetic heading. So it's like your iPhone, right? It tracks the number of steps you take. You take your 10,000 steps a day, right? Or your little Fitbit. It's the exact same thing. It's recording a lot of these fine movements. And then the little package pops off the animal. There's the data logger. It's attached to this little float package with an antenna. It pops off, floats to the surface. We go pick it up, and then we're able to download all the data and get a good fine scale idea of what the daily activities are of these sharks when they're down here. One of the advantages to doing this sort of work when they're here is that these sharks are milling around here for a couple of months close to shore. So when these packages pop off, we have a very high probability of actually getting them back again. We don't want to do it when they're migrating because when it pops off, it might be in the middle of, Cape Canaveral or something, and it may be difficult to get. But when they're down here for a few months, they're here. And so when we tag them, we're able to get these packages back with a reasonable reacquisition rate. So that's something that we're working on now. And in fact, I have a student out on the boat today, right now. That's him. That's Ryan. He's looking for one of these packages, even as we speak. I haven't got the call to say he has it yet. So I also told him he can't come home till he has it. So we'll see. But that's one other aspect that we're doing, is looking at this sort of fine-scale data logging. What are the animals doing when they're around? The other thing that we're taking advantage of now are drones. Have you guys flown drones? Anybody here flown a drone? Yeah, they're really fun. If you haven't done it, you should try it. They're remarkably inexpensive now. They're easy to fly. They have high-quality cameras, and they're useful because you're able to get really good data from these, toys, basically. And because these sharks are so close to the beach, it makes it easy for us. We can literally walk down to the beach, take our drone, throw it up in the air, and fly it over a school of sharks and get some really good video footage. We use these drones for a variety of things. We use it to cheat when we go fishing because we fly the drone and we see where the sharks are. And once we know where the sharks are, whoops, my video's not playing. Oh no, where's my sharks? Oh, sorry about that. Oh no. Oh, whoops. Well, we use it to cheat when we're flying. We see where the sharks are, and that's where we set our fishing gear. So that's the one thing we're doing. We're also able to fly it over huge schools like this and get an idea of social behavior. Are the sharks all swimming in a polarized manner? Are they sort of milling around doing their own thing? Are they, what's the swimming kinematics? Are they all swimming at the same speed? There's a lot of analysis, a lot of data that you can extract from footage like this. You can also use it for storytelling. Just showing you this and showing you the numbers of sharks that you get in these aggregations gives you an idea of what the what we're looking at, and helps you appreciate the sheer numbers of sharks in these groups. We also use it for things like predator-prey relationships. So you can look at this great hammerhead shark tracking down these blacktips. And what I want you to watch here is how close that hammerhead gets before the blacktips even know it's there. All right? And the blacktips are just sort of calmly milling around, minding their own business, when this hammerhead is sneaking up behind them. And you'll see how close he gets before he bolts, and then the hammerhead, and then the blacktip bolt. Look at that. And then as soon as he takes off, he scares all his buddies, and the blacktip gets nothing. I mean, the hammerhead gets nothing. Poor hammerhead. But he tries again. I'll let you watch a little bit more, just because it's so entertaining. But the hammerhead keeps trying. The blacktips are a little spooked now, and so they're not going to let him get quite as close. They're a little bit more wary. And so despite the fact that he's trying and trying and trying, it's hard for him to get a blacktip. And so it enables us to get this sort of predatory behavior, predator-prey behavior, that's so difficult to study in the wild, next to impossible to study in the marine system. And realizing that these blacktips may be sharks, but they're not only the predators, they're also the prey to bigger sharks as well. And so drones enable us to collect this sort of data like swimming kinematic data. What's the tail beat frequency of these sharks as they're cruising versus when they're scared by the hammerhead? What's the velocity of the hammerhead as it's swimming? A lot of these fundamental questions that we're able to answer with this drone footage. Go, 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 and oh, I cut it before anything bad happened. But you get the idea. This stuff is how big was that hammerhead? That hammerhead was probably about, those blacktips are the same as me. I'm 5'9". So those blacktips are he's about 2x that. He's 12 feet maybe, close to 12. So they're big sharks. And we've caught them on occasion, accidentally, when we're catching blacktips. And they will take our floats and sink them underwater. They're so strong, those big hammerheads. They're impressive. When you see them cruising beside the boat, they're like little submarines, I swear. They're just enormous things. But this sort of drone technology enables us to address a lot of questions and see things that we could have never seen before. And again, it opens the way for us to answer a lot of interesting questions. And the other thing that we're doing is taking advantage of cheap cameras. You guys know what GoPro cameras are? Nice little, great little cameras. They're small. They're relatively inexpensive. And we use what's called a block cam. It's literally a concrete block with a GoPro stuck on it and a float so we can find it again. And what we do is when we go out fishing, we'll take this, we'll drop it overboard, and then we'll drive away and we'll leave it. It'll just be recording video the whole time while we're off doing something else a mile down the road. And now, anytime a shark swims by, we're able to record that. The camera records it. We go back, we pull it up, we download the video in the lab and see who swam by. And we're able to get some really cool stuff. This is just an example of a block cam set up off Palm Beach in the wintertime, showing that you can get lots of sharks. And because it's not baited, it's not artificial, it's just sitting there observing, you're seeing sharks in their natural state as they're cruising by, and it's, as far as they're concerned, it's just a little rock on the reef. And so they swim right on past without paying any attention. But again, we can get counts of not only the numbers of sharks, but sex, are they males or females? How many are there? You can look at swimming kinematics. You can use this to look at prey abundance as well. We are also looking at the number of little bait fish that swim by. How many bait fish are there? When are they there? What species? And we're able to answer some of those larger ecosystem-based questions by simple technology like a GoPro camera on a concrete block, right? And so I'll just end by pointing out that humans and sharks have been around for a long time. They've been here way longer than we have, but we've been coexisting with them for a relatively long time, and it's mostly been a good relationship. We are not the ones who are, we're doing more damage to them than they are to us, basically. And despite the fact that you can have literally hundreds or thousands of sharks right off the beach, we can also go to the beach and have a good time, and the probability of you having a negative encounter is vanishingly small. It's not non-existent, I'm not saying that. You might get bitten, but the chances are small. And so I would encourage you to not be afraid of the sharks. Don't be concerned when they're here. Rejoice in the fact that we have them. I mean, you know, I always tell people that it's a good thing when you have lots of top-level predators. It means you've got a good solid base, a good, you know, a good support system to enable us to support thousands of these top-level predators. We must have a pretty healthy and robust ecosystem to do that. So when you see the sharks here, don't be afraid. Just consider yourself fortunate that we have them. And if you get a chance, go to the beach and see them. These blacktips jump and spin out of the water and splash down. They're really cool. And so I will end by thanking our sponsor, the Colgan Foundation, are largely responsible for funding this work. It's all thanks to them that we're able to do all of this. And if you are on social media at all, I encourage you to follow us on Twitter and Instagram at @SharkMigration, and check out our Facebook page, FAU Shark Migration, as well. With that, I'm going to end it early and say thank you guys so much for the invitation.